Now let's have a look at the main line of the solution of exercise 10.7, which is a search model of unemployment. The Bellman equation of the problem is this. You can find the basics of the problem in the textbook and the user guide, I mean the solution guide. I cannot and I don't want to go over the whole solution. I want to show you the most beautiful parts of the solution. First, we note that the right line, so this is the search line of the problem. The search line is a constant. So we can say that the search line is a constant A. We don't know the constant, not yet. We don't know the value function. We only know that there is a value function, and the expected value of the value function with respect to a probability measure, this is a density function, it leads to a constant. Then we note that at zero wage, the acceptance line, so this is the acceptance line. So this is the search line. And let's call this part the acceptance line. Okay, so here the worker accepts the job offer, and here the worker refuses the job offer, the wage offer, and chooses to search. So we realize, second, we realize that at zero wage, the acceptance line has a lower value than A, because this is 0. So altogether, it is sure that at zero wage, again, at zero wage, the acceptance line leads to a lower value than A. Then we realize that at zero wage, the value function is A. How? On the one, so there are two options. If the worker thinks that the acceptance line is higher, then he chooses the acceptance line, the value of which is beta times the value function, from which it follows that this equality holds, from which it follows that the value function at zero wage is 0. At the same time, and on the other hand, the search line has a higher value. It is positive for sure. So at zero wage, the decision problem is the following. So it follows we saw that this is 0. This is 0. So it follows that the value function at 0 wage is A. Okay. We can write. Okay. It is the same. All right. Given that the discount factor lies between 0 and 1, the acceptance line, that is this function, the value of the acceptance line at 0 wage is lower than A. At the same time, so so at 0 wage, the value of acceptance line is lower than A for sure. At the same time, at the maximum wage, the acceptance line is higher, has higher value than the search line. So what we know is if the wage is 0, then the acceptance line has a lower value than the search line. Okay, and if we are at the maximum wage, the opposite is true. Intuitively, the meaning is if the worker is offered the maximum wage, it would make no sense for him or her to reject the job offer, so he or she accepts the wage offer if the wage offer is the maximum wage. We have already seen this equality, but we haven't yet checked this inequality. If the discount factor tends to 1, then the value of the acceptance line tends to A, and because of the fact that U, the utility function, is strictly increasing, the acceptance line the acceptance line must be higher than A, even if V, the value function, is only increasing, not strictly increasing, only increasing. And if the discount factor tends to 0, then the search line, the value of the search line also tends to 0, while the value of the acceptance line tends to a number which is definitely higher than 0. So we have this decision problem. Let's dig deeper. So this is the decision problem. Let's compare the values of the two lines at distinct wages. If the wage is 0, then this is the acceptance line. Which can be simplified to beta A. This is the value of the once again, this is the value of the acceptance line at 0 wage, while at the maximum wage is higher than A for sure. So on the basis of the Bolzano theorem, the line, the graph of the acceptance line will have only one intersection with the constant graph of the search line. So again, because of the Bolzano theorem, there is only one wage level in this figure where, so this is A, and there is a unique wage level that separates the two sections of the value function. So this point of intersection gives us that unique wage that separates the value function into two sections. So based on the previous part, we can say that the value function has two sections. This latter part comes from the fact that here this is the value function from which it follows Yep. And finally, on this section, along this section, the value function can be described with this formula. This is an unfortunate situation because to know the value function, we need to know this particular wage level and A, the constant A. However, constant A can be calculated only if the value function is known. So we need to find a way in which this interdependence can be eased or released. So let's use two facts. First, we need to realize that at the unique wage level, which is called the reservation wage, the two sections of the value function are equal. From this, with some easy steps, we can get to a very useful and simple formula from which it follows that the following equality holds between A and the reservation wage. This is equality 3 of the textbook. Second, we can use the fact that we know the two sections of the value function, even if we don't know the exact values of A and the reservation wage. But we know that the value function has two sections. So from the definition of A, we can get to some interesting results. First, we can divide the integral between 0 and W upper bar. So we can divide the integral into two sections separated by the unique reservation wage, because between 0 and the reservation wage on the one hand, and the reservation wage and the maximum wage, we can substitute with the two sections of the value function. So and on the other hand, we just substitute the density function with the distribution function. And on the other hand, we apply the formula of the other section of the value function. And again, we use not the distribution function. We use a distribution function instead of the density function. All right. With some steps, we get to it's technical and you can do this. We get to the following equation. All you need to do is to creatively use the distribution function and the density function. You can start with the density function and then switch to the distribution function when necessary. And this is equation 5. By connecting 3 and 5, we get the following equation. We need to find a way to solve this equation to the reservation wage, and this is a very beautiful solution, so let me show you some details. From this, it follows we are getting rid of the ratio on the right hand side. From which we can write the following. I don't need these brackets. Here we are using the distribution function as defined in the textbook in the usual way, so there is no surprise in the definition Stokey and Lucas used. If it is true, then it is also true Yep. And finally, we get to this equation. There is only one fly in the ointment, in our ointment, because the intervals on which we integrate are not the same, and we need to sort out this problem. So here we will do this by using the complements of the intervals. So here we use the fact that no, sorry. So this is what we are going to use here. Okay. And by using this fact, we can put the integrals on the same intervals. This is a new term coming from the complements. The complement interval, I mean. All right, and two more lines. Here we have two separate integrals on the same interval, and it's not too difficult to put them together because integrals are linear. We have covered this in the lecture devoted to measure theory and integration. So everything was useful in the end. So finally, we have this equation, which is the equilibrium that gives us the unique value of the reservation wage. So it can be solved to the reservation wage. To do so, we should note that this is a cross. Okay, so this is a cross or something, the intersection of which leads to the reservation wage, because both sides are the functions of the wage. So let's have some looks at them separately. This is the left-hand side. This is the left-hand side. This is strictly increasing in the wage because function u is strictly increasing in the wage. The right-hand side is more complicated, and this is the point where the mathematics becomes really, really beautiful, because we need to integrate by parts, and this is a technique that is so beautiful. So let's separate the integral into two parts by using the linearity of the integral. Okay, we have just done the opposite, but now it's gonna be more comfortable to integrate separately. So we have two parts. This is part 1 and this is part 2. Part 1. This is simple. We need to integrate with respect to the lower bound of the integral, and by derivating this expression, I mean expression 1, section 1 of the right hand side, we receive this function. It's an easy feat. 2. Section 2. We need to realize, this is very, very, very important. We need to realize that this wage is not the variable of the integral. So for simplicity, we can say that section 2 of the integral can be simplified because of the difference in variables. We can put the utility function to the front, in front of the integral. Okay, and now, so this is still section 2 of the problem in a different way. And we need to derivate section 2 prime with respect to w, which is simple because we derivate the first part and use the second part with no change, following the basic rules of derivation. And then we don't do anything with the first part and derivate the integral with respect to the lower bound. So this is what we have on the one hand, and this is what we have in the other hand, and it's easy to realize that this part and this part cancel each other. So finally, the right hand side is decreasing in w because the utility function is strictly increasing in w, so the negative sign makes the whole expression negative. So the left hand side is strictly increasing, the right hand side is strictly decreasing, so there is a unique reservation wage from which A can be calculated. By this way, we could completely characterize the value function. One more remark: reservation wage is called reservation wage because this is the policy function in this case, because on the basis, so the agent, the worker, makes his or her decisions on the basis of this unique reservation wage. If the wage offer is lower than the reservation wage, the worker chooses to search, and if the wage offer is higher than his or her reservation wage, he or she accepts the job and wage offer. That's all.